Today we will learn consolidation test. Scope of the test. This test is performed to determine the magnitude and rate of volume decrease that a laterally confined swell specimen undergoes when subjected to different vertical pressure. From the measured data, the consolidation curve pressure-void ratio relationship can be plotted. This data is useful in determining the compression index, the recompression index and the pre-consolidation pressure or maximum past pressure of the swell. In addition, the data obtained can also be used to determine the coefficient of consolidation and the coefficient of secondary compression of the swell. Standard reference ASTM D2435 standard test method for one-dimensional consolidation properties of swell. Significance. The consolidation properties determined from the consolidation test are used to estimate the magnitude and the rate of both primary and secondary consolidation settlement of a structure or an earthfill. Estimates of this type are of key importance in the design of engineered structure and the evaluation of their performance. Equipment. Consolidation device including ring, porous stone and load plate. Dial gauge 0.0001 inch is equal to 1 on dial. Sample trimming device, glass plate, metal straight edge, clock, moisture can, filter paper. Test procedure 1. Weigh the empty consolidation ring together with glass plate. 2. Measure the height h of the ring and its inside diameter small d. 3. Extrude the swell sample from the sampler, generally thin walled shell by tube. Determine the initial moisture content and the specific gravity of the swell respectively. 4. Cut approximately a 3-inch long sample. Place the sample on the consolidation ring and cut the sides of the sample to be approximately the same as the outside diameter of the ring. Rotate the ring and pare off the excess swell by means of the cutting tool so that the sample is reduced to the same inside diameter of the ring. It is important to keep the cutting tool in the correct horizontal position during this process. 5. As the trimming progresses, press the sample gently into the ring and continue until the sample protrudes a short distance through the bottom of the ring. Be careful throughout the trimming process to ensure that there is no void space between the sample and the ring. 6. Turn the ring over carefully and remove the portion of the swell protruding above the ring. Using the metal straight edge, cut the swell surface flush with the surface of the ring. Remove the final portion with the extreme care. 7. Place the previously wet saran covered glass plate on the freshly cut surface. Turn the ring over again and carefully cut the other end in a similar manner. 8. Weigh the specimen plus ring plus glass plate. 9. Carefully remove the ring with specimen from the saran covered glass plate and peel the saran from the specimen surface. Center the porous stones that have been soaking on the top and bottom surface of the test specimen. Place the filter papers between porous stones and swell specimen. Press very lightly to make sure that the stones adhere to the sample. 10. Being careful to prevent movement of the ring and porous stones, place the load plate centrally on the upper porous stone and adjust the loading device. 11. Adjust the dial gauge to a 0 reading. 12. Apply loads on the load plate. First start by 25 kPa, then after 1 day 50 and follow loadings according to data sheet. 13. Record the consolidation dial readings at the elapsed times given on data sheet. 14. At the last elapsed time reading, record the final consolidation dial reading and time. Release the load and quickly disassemble the consolidation device and remove the specimen. Quickly but carefully blot the surfaces dry with paper toweling. The specimen will tend to absorb water after the load is released. 15. Place the specimen and ring on the saran covered glass plate and once again weigh them together. 16. Weigh and empty large moisture can and lid. 17. Carefully remove the specimen from the consolidation ring, being sure not to lose too much swell, and place the specimen in the previously weighed moisture can. Place the moisture can containing the specimen in the oven and let it dry for 12 to 18 hours. 18. Weigh the dry specimen in the moisture can. Analysis. Determination of pre-consolidation pressure P0. 1. By visual observation, establish point A at which E log P plot has minimum radius of curvature. 2. Draw a horizontal line AB. 3. Draw the line AC tangent at A. 4. Draw the line AD, which is the bisector of the angle BAC. 5. Project the straight line portion GH of E log P. Plot back to intersect line AD at F. The abscissa of point F is the pre-consolidation pressure PC. Determination of T50 from deformation versus time curve. 1. By visual observation, establish point 1 at which curve start falling. Take the time T1 from the point 2. Take another point 2 on curve from T2 is equal to T1 by 4. 3. Draw the horizontal line at a distance from point 2 just equal to the distance of point 1 and 2. Record the deformation reading as D0. 4. Take another point D100 as like figure. 5. Take the point T50 from D50 is equal to D0 plus D100 divided by 2. Determination of T90 from deformation Bs under root time curve. 1. Extend the straight portion of the curve and note point T1. 2. Take another point T2 is equal to 1.15 T1 and draw a straight line joining T2 and the first point of the curve. 3. Take point D90 and T90 from the intersection point of the curve and the straight line from T2.